Hello viewers, in today's lecture we are going to solve some important problems on differential equations, and here under differential equations we will solve problems related to variables separable form. Now we know that if we have a differential equation of this form, dy over dx is equal to say fx, and here we have g of y, then here we have the variables x and y, and y is known as the dependent variable and x is known as the independent variable. Now here to solve this differential equation, what we do, as the name suggests, we have to separate the variables. So here we'll separate the variables x and y. It means that we'll associate all the functions of x with dx and all the functions of y with dy, right? So what does it mean? It means we have to associate g of y with dy, right, here, and here we have to associate this fx with dx, and then we will integrate both sides, and here with respect to y, and here we'll integrate with respect to x, and we'll have the constant of integration, right? So these two integrals can be calculated by the techniques of integration, and finally we get the required solution. Now viewers, let us take this problem. Here we have dy over dx is equal to e raised to x plus y plus x square e raised to y, and here we have to solve this differential equation. Now what we will do, we'll separate the variables. So here this expression can be written as e raised to x times e raised to y, right? So this expression is written like this, and then we have here x square, and here we have e raised to y. Now we can take e raised to y common, so we have e raised to x plus x square, and this is the function of y and this is the function of x. So here we have dy over dx. Now we'll associate all the terms having x in it with dx, and the terms having y in them will be associated with dy. So here we have dy over e raised to y, and here we have e raised to x plus x square times dx, right? Now we'll integrate both sides, and here we have the constant of integration, and this is e raised to minus y dy, and here the integral of e raised to x is e raised to x, and this is the integral of x square is x cube over 3 plus c, and the integral of e raised to minus y is minus e raised to y, and this is e raised to x plus x cube over 3 plus c, right? Now if we take this negative sign to this side, we can also express it like this: e raised to minus y, here we have e raised to x, and here we have x cube over 3, and here we will have minus c, which can be represented or which can be replaced by some other constant c1. c1 is minus c, right? And we can leave the solution at this point, but if we want to simplify it further, we can take log of both sides. So if we take log of both sides, we have log e raised to minus y, here we have log of minus e raised to x minus x cube over 3 plus c1, and here we have minus y, because log of e raised to a is a log e, and log e is 1, so we have a, right? So here we have log minus e raised to x minus x cube over 3 plus c1. So this is the required solution, or y can be written as minus log minus e raised to x minus x cube over 3 and plus c1. So this is the required solution. Now let us solve this differential equation. Here we have x minus 1 times dy over dx is equal to 2x cube y. Now again here we'll separate the variables, so we can write dy as dy over y, taking this y to the denominator of dy, and here we have 2x cube divided by x minus 1, and here we have dx, right? So we have separated the variables. Now we'll integrate both sides. Here we have the constant of integration, right? Okay, so now here we have log of y, and here we can make use of the substitution method. So to integrate this function, we'll put let t is equal to x minus 1, so we have dt is equal to dx, and t plus 1 is equal to x, right? So this integral now becomes 2 times for x cube we have t plus 1 cube, and for x minus 1 we have t, right? And here we have dt plus c. Now this is log of y. Now taking 2 out of the integral, here we have 2, and t plus 1 cube can be written as t cube plus 1 plus 3t square plus 3t divided by t, right? And here we have dt plus c. Now this can be written as 2 times, here we have t square plus 1 over t plus 3t plus 3, right? And here we have dt plus c. Now we have log y is equal to the integral of t square is t cube over 3, and this is log of t, and here we have 3t square by 2, and here we have 3t plus c, right? So now again we have to resubstitute the value of t here, so the solution becomes log y is equal to 2 times, here we have x minus 1 cube divided by 3 plus log of x minus 1, this is 3 by 2, and here we have x minus 1 square plus 3 times of x minus 1 and plus c. Now viewers, this is the required solution of this differential equation, and if we further solve it, we get log y is equal to 2 by 3 x cube plus x square plus 2x plus 2 times of log x minus 1 and plus c1, right? And c1 is some other constant, right? So here what we have done, we'll expand x minus 1 cube, and here we'll expand x minus 1 square, and here we'll write 3x minus 3. And if we simplify the expression, we'll arrive at this result, right? And this is for you as a practice exercise to get this result from this expression. Now let us take this problem. Here we have sine inverse dy over dx is equal to x. So here what we will do, we'll take this sine inverse y to this side. So we have dy over dx is equal to sine x, right? Now see, here we'll have this sine x. So we separate the variables. Dy is equal to sine x dx, and integrating both sides, we have c is the constant of integration. So here we have y, here we have minus cos x, because the integral of sine x is minus cos x, plus c. So this can also be written as y plus cos x is equal to c. So this is the required solution of this differential equation. Now let us take this problem. Here we have x square minus yx square dy plus y square plus x square y square dx equal to 0. Now here again we'll make use of variable separable form. So taking x square common from this expression, so we have 1 minus y dy plus, here we'll take x square common, so we have 1 plus x square, and here we have dx, that is equal to 0. Now this can be written as x square 1 minus y dy, and taking this term to the right hand side, we have minus y square 1 plus x square dx. Now separating the variables, we have 1 minus y over y square dy is equal to minus 1 plus x square over x square, right? So this is the separation of variables. Now this can be written as 1 over y square minus 1 over y. Here we have dy, and here we have 1 over x square plus x square. If we separate it, we have 1 over x square plus 1, and here we have dx, right? Now integrating both sides, we have the constant of integration. Now the integral of 1 over y square is minus 1 over y. Integral of 1 over y is log y, and here we have minus sign, and integral of 1 over x square is minus 1 over x, and the integral of 1 is x, right? And here we have c. Now this can be written as minus 1 over y minus log y, and this is 1 over x minus x plus c. Now multiplying throughout by minus 1, we have 1 over y plus log y. Here we have minus 1 over x plus x, and here we have minus c, and we can write plus c1. So c1 is equal to minus c, right? So this is the required solution of this differential equation. Now let us take this problem. Here we have to solve this differential equation. Dy over dx is equal to 1 plus x plus y plus xy. So viewers, we can write it as dy over dx. Here we have 1 plus x, and here if we take y common, so we have y 1 plus x. Now taking 1 plus x and 1 plus x common, we have dy over dx as 1 plus x times 1 plus y, right? So we have expressed this term as a product of two factors. And now separating the variables, we have dy over 1 plus y. Here we have 1 plus x and dx, right? Now integrating both sides, here we have the constant of integration. Now the integral of 1 over 1 plus y is log 1 plus y, and here we have the integral of 1 as x. Integral of x is x square over 2 plus c. So this is the required solution of this differential equation. Now viewers, let us take this problem. Here we have log of dy over dx is equal to ax plus by. Now here we know that log of f of x is equal to, say, a, then this expression implies that f of x is equal to e raised to a, right? So here we will apply this rule to this equation first, right? So this is log of f of x, and if log of f of x is equal to a, f of x is equal to e raised to a. So here dy over dx now becomes e raised to ax plus by, and this becomes dy over dx is equal to e raised to ax times e raised to by. Now we can separate the variables here. This is the function of x, this is the function of y, so we can write dy over e raised to by is equal to e raised to ax dx. Now this is e raised to minus by, dy is equal to e raised to ax dx, and now integrating both sides, we have here the constant of integration. Now e raised to minus by, the integral of this function is e raised to minus by divided by minus b, and here we have e raised to ax divided by a plus c, right? Now we can also simplify it further by taking this term to this side. So we can also write it as e raised to ax over a plus e raised to minus by divided by b plus c is equal to 0. So this is the required solution of this differential equation. Now let us take this problem. 1 plus y square tan inverse x dx plus 2y 1 plus x square dy is equal to 0. Now here again we'll separate the variables. So this can be written as 1 plus y square tan inverse x dx equal to minus 2y 1 plus x square dy, right? Now viewers, this can further be written as taking 1 plus x square here. So we have tan inverse of x divided by 1 plus x square dx, and here we have minus 2y, and taking this factor to the denominator, 1 plus y square and dy. Right, now we have separated the variables, so now we can integrate, and here we have the constant of integration. Right, now viewers, let us see this integral. Here if we put t is equal to tan inverse x, then we have dt over dx is equal to 1 over 1 plus x square. So dt is dx over 1 plus x square. Now here we have dx over 1 plus x square, so that is dt, and here for tan inverse x we have t. Right, okay, and here we have minus, and this is 2y divided by 1 plus y square dy plus c. Now this is t square over 2, because the integral of t raised to 1 is t square over 2. This is minus, and c, here the derivative of 1 plus y square is 2y, so here we have the integral log of 1 plus y square, and here we have plus c. Substituting the value of t as tan inverse x here, we have tan inverse of x square divided by 2 is equal to minus log 1 plus y square plus c. So this is the required solution of this differential equation. Now let us take this problem. Here we have dy over dx plus 2xy is equal to y. Now viewers, this can be written as dy over dx, taking this 2xy to this side, that is right hand side, we have y minus 2xy, and now this can be written as taking y as common, so we have 1 minus 2x, and now we can separate the variables, so we have dy over y, and here we have 1 minus 2x dx. Right, now integrating both sides, and here c is the constant of integration. Now the integral of 1 over y is log of y, and this is the integral of 1 is x, and here we have x square over 2, because the integral of x is x square over 2, and here we have plus c. 2 and 2 get cancelled, so we have log y is equal to x minus x square plus c. So this is the required solution. Now let us take this problem. Here we have to solve dy over dx is equal to e raised to minus y cos x, and we are given the conditions y0 is equal to 0. So what does it mean? It means that when x is 0, y is 0. Right, so let us solve it by separating the variables. So we have dy over e raised to minus y, and this is cos x dx. Now this can be written as e raised to y dy, and here we have cos x dx. Now integrating both sides, we have c as the constant of integration, so here we have e raised to y, because the integral of e raised to y is e raised to y, and the integral of cos x is sin x plus c. Now this is the required solution of this differential equation. In fact, this is the general solution, right? General solution, because here c is the arbitrary constant. Now let us substitute these values to get the value of c here. So when x is 0, y is 0. So here we have e raised to 0 and sine 0 plus c e raised to 0 is 1, sine 0 is 0, plus c, and that is c. So the value of c is 1. Substituting it here, we have e raised to y is equal to sine x plus 1. So this is the required solution, and this can further be written as y log e. Taking log of both sides, we have log of 1 plus sine x, and log e is 1, so we have y is equal to log 1 plus sine x, right? Now let us solve this problem. Here we are given 1 plus y square 1 plus log x dx plus x dy is equal to 0, and the initial conditions, these are known as initial conditions or boundary value conditions, right? So these conditions are known as boundary conditions or initial conditions. So we have to solve this differential equation. Now separating the variables, we can write it as 1 plus y square, this is 1 plus log x dx equal to minus x dy, right? Now this can be written as 1 plus log x dx, and taking x to the denominator of 1 plus log x, and here we have minus dy divided by 1 plus y square, right? Now integrating both sides, we have the constant of integration. Now this can be written as this integral is actually 1 over x plus log x over x, right? And here we have minus, and the integral of 1 over 1 plus y square is tan inverse of y plus c, right? Now the integral of 1 over x is log of x, and plus to find the integral of log x over x, what we do, we'll put t is equal to log x, so dt is equal to dx over x, and this integral becomes log x is t and dx over x is dt, and the integral of t dt is t square over 2, and this is log x square over 2. So here we can write log x square over 2, and this is minus tan inverse of y plus c. Now viewers, here we have to find the value of c by using these values. So when x is 1, y is 1. So when x is 1, log x is log 1, and log 1 is 0. So here we have 0, here we have 0 square over 2, and here we have tan inverse of 1 because y is 1 plus c. So this side is 0, and here we have minus tan inverse 1 is pi by 4 plus c, so c is equal to pi by 4. Now substituting the value of c here, the particular solution of this differential equation is log x plus log x square divided by 2 is equal to minus tan inverse of y plus pi by 4, right?